Students, welcome to my YouTube channel. In this video lecture, we are going to solve some of the questions from this chapter, Revision Questions, Oxford General Navigation book. Very important for your exam preparation. So let's start with question number 132 first. How do rhumb lines, with the exception of meridians, appear on a polar stereographic chart? So on a polar stereographic chart, rhumb lines are lines concave. Concave means away from the nearest pole. So it is option number A. Okay. Remember all the properties of all the charts. Mercator, Lambert's, polar. 4 o'clock 22 minutes. You are 185 miles from a VOR at flight level 370. You need to descend at a rate of 1800 feet per minute so as to be at flight level 80. Overhead VOR. Your speed at cruise is 320 knots. Speed at descent is 232 knots. What is the latest time to commence a descent? So interesting. So let's check this. Here is your aircraft at 37,000 feet. VOR station is here. You have to be here at 8,000 feet. Okay. The time is 0422. Okay. And your distance is 185. So rate of descent is 1800 feet per minute. You have to descend. Total descent is equal to 57,000 minus 8,000 is equal to 29,000. So time taken to descend will be equal to 29,000 divided by 1,800, which is 16 minutes. Okay, a total of 16 minutes. Okay, for descent. Next, ground speed in level cruise is 320 knots and the distance. So right here, cruise ground speed is 320 knots. Distance is 185. So at this speed you will take how much time to cover this entire 185 nautical miles? You will take 320, 185 divided by 320 is equal to 34 minutes. You will take 34 minutes. Okay. So the latest time that you will begin will be, so you will reach, this is 0422 and with a speed of 320 knots you will reach here in 34 minutes. So 4 hours 22 minutes plus 34 minutes is nothing but 4 hours 56 minutes. You will reach here at 4 hours 56 minutes. But during descent, okay, During descent, you are not going to descend at 320 knots speed. You are going to descend at a speed of 232 knots. So the time taken will be, in that case, during descent time will be distance by speed, which is 185 divided by 232, is 47 minutes. Will take 47 minutes. 47 minutes means 4 hours 22 minutes plus 47 minutes is 5 hours 9 minutes. Okay, so you will reach VOR station at 5 hours 9 minutes. So out of this total 47 minutes, 16 minutes will be spent in actual descending. Okay, in actual descending. Okay, so what you will do is, first this 16 minutes is relevant to you and this 34 minutes is relevant to you. So you will not start descending directly. So your aircraft will first fly to here and then from here it will descend over this VOR. Okay. So total cruising time is 34 minutes. Okay, total cruising time is 34 minutes. So out of those 34 minutes, 15 minutes will be spent in cruising. So 34 minus 16 is 18 minutes. So first 18 minutes you should cruise. The next 16 minutes you should descend. So 0422 plus 18 is 4 hours 40 minutes. At 4 hours 40 minutes you should start descending so as to be over VOR at 4 hours 56 minutes. Okay. So you should start at Bravo, 4 hours 41 minutes, the closest. Next, heading is given, variation is given, drift is there, speed is there. At A, relative bearing to an NDB is 325. 5 minutes later, the relative bearing becomes 280. What is the true bearing and distance from aircraft to the NDB? So, first, the heading of 165 and a relative bearing of 325. DM to the station is heading plus relative bearing, which is 165 plus 325, that is 130. Okay. At B, 5 minutes later, the relative bearing becomes 280. Heading is the same, 165. So QDM will be equal to 165 plus 280, that is 085. That means your NDB station is here. When you are at location A here, from this location, track towards the station QDM is 130. QDM is 130. At location B, the track to the station is 085. 085. You have to find distance from B. This distance you have to find, and you have to find true bearing. Okay, you have to find true bearing. Magnetic bearing we have. Magnetic bearing to the station is 085. We have to find true bearing to the station. So true bearing to the station will be nothing but variation. Variation is how much? Variation is 25 west. So variation 25 west. Magnetic will be best. So true will be less than magnetic. So 85 minus 25, 60. So true bearing to the station will be 060. Now let's find distance. Speed is how much? Speed is 360. Time traveled is 5 minutes. So distance will be equal to speed into time, 360 into 5 minutes, that is 30 nautical mile. So distance traveled is 30. Now this angle is how much? This angle is equal to 130 minus 85. Okay, this is 85, this is 135. So difference between them is 0.45. 0.45. Okay, 0.45. I will use another slide. Okay, so this is, so 90 minus 135 is 45, and 90 minus 85 is 5. This is 40 degree, this is 5 degree, total is 45. Total is 45. Next, if this is 45 degree, so this and this side will be equal. Okay, this side will be equal to this side. This is A, this is B, this is your NDB station, right? Now this distance A to B is how much? 30 nautical miles. It's 30 nautical miles. Okay. Now these two sides will be equal. So now how to find that? We will use 1 in 60 rule formula, wherein angle equals to distance of track upon distance gone to 60. Distance of track upon distance gone into 60. So angle is 45 degree. Distance of track is 30. Distance gone we will find. Distance gone is nothing but this distance. Okay, into 60. So distance gone will be equal to 30 into 60 by 45. That is equal to 40 nautical miles. So this distance is 40 nautical miles. Okay, this distance is 40 nautical miles. The isosceles a triangle. Okay, so this side AB will be equal to this side. So this will also be equal to 30. So the correct answer will be option Charlie. Okay, will be Charlie. 137. What is the diameter of the earth? Now circumference equals to pi r. We all know that circumference of the earth in kilometers is 40,000. So r will be equal to 40,000 divided by 2 into 3.142. So 2 into 3.142 is 6.284. So 40,000 divided by 6.284 is equal to 6365 kilometers. Radius is 6365 kilometer. Diameter will be twice of radius. So twice of 6365, that is equal to 12,731 kilometers. So correct option will be option Bravo. Aircraft flies 100 statute miles in 20 minutes. Now 100 statute mile is equal to how many nautical miles? 1 nautical mile is 1.15 statute miles. So 100 statute mile will be equal to 100 divided by 1.15. So 100 divided by 1.15 is 87 nautical miles. So aircraft travels 87 nautical miles in 20 minutes. In that case, speed will be 87 divided by 20 minutes. So 87 divided by 0 hours 20 minutes is 261 knots. Now at this speed, what time will you take to fly 215 nautical miles? So time taken will be distance 215 divided by speed 261. 49 minutes, which is equal to option A, closest option. So with this we come to the end of this lecture. Do practice these questions many times till you gain perfection. Do not miss my next lectures in which I will be solving next questions from this chapter. Subscribe to this channel and like this video. Don't forget to share it with your friends. Thank you.